Now next article is expression for gravitational potential energy. Work done against gravitational force in displacing an object through a small distance dr appears as an increase in potential energy. Just we learn work done act as a increase in potential energy. So this change in potential energy is equal to F into dr, force into displacement. So minus sign indicate that this work is done against the gravitational force. So minus sign is there. Now here, for displacement of object from initial position Ri, I for initial, to final position Rf, a change in potential energy can be obtained by integrating this equation. So delta U is equal to integration of du within a limit Ri to Rf. Ri initial position, Rf is the final position. Now let me substitute this value of du minus Fg into dr. Minus Fg, it is a gravitational force. F is a gravitational force. But you know that gravitational force by Newton's law of gravitation is minus, this is gmm by r square into this unit vector r cap. Okay, this is a gravitational force. So Fg is equal to. Now let me substitute that gravitational force. So here, after substituting this minus minus get cancelled, we get gmm by r square into r cap r bar. Now this integration we have to solve here. We can take the constant term outside the integration. Capital G is constant, capital M is constant, small m is constant. So this integration of dr by r square. So this unit vector as this dr bar is along r cap, that you remember. So integration of dr by r square, it is coming minus 1 by r. Let I tell you integration formula. Integration x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. This is a formula. You have to learn integration in the mathematics. Now here, integration of this is dr by r square. It is similar to integration r raised to minus 2 into dr. Now use this formula. So r raised to minus 2 plus 1 divided by minus 2 plus 1. So it is coming r raised to minus 1 divided by minus 1. Okay? So that we can write minus r raised to minus 1 by 1. Or we can write minus 1 by r raised to plus 1. So this is r minus 1 by r is the integration. And then the limit we are written here ri to rf. You can remember here this integration of 1 by r square dr is coming minus 1 by r. Now in the mathematics, when you learn this integration chapter, you come to know in more detail how we get this integration. But in today's lecture, I'm not explaining any integration. You have to remember some formulas. So we get after substitution of limit. Now we have to do one thing, this g as it is, m as it is, small m as it is. Now we have to do one thing, minus 1 by upper limit we have to substitute instead of r. So minus 1 by rf. Then minus sign, and then lower limit you have to substitute. It is minus 1 by lower limit is ri. So bracket complete. So this minus minus plus. So it is written first ri, and then minus 1 by rf is written later. I hope everyone understood how we get this integration. This is the mathematics. Then after that, so we have to substitute the limit, and after substitution of limit we get this is the increase in potential energy. So change in potential energy corresponding to the work done against the conservative force. So here we can consider that if Ri is equal to infinity, the point with a zero potential energy point we consider, this is the initial point. So it is at infinity distance. So then Ri is infinity. If we substitute Ri is infinity, then we get, so potential gravitational potential energy is equal to 1 by infinity is 0. So we get a gravitational potential energy is equal to minus gmm by r, and this is expression for gravitational potential. Now concept of potential. So gravitational potential is given by formula, the gravitational potential energy is the gravitational potential into mass, or we can write gravitational potential is equal to gravitational potential energy per unit mass. So we can write a formula, this V is equal to U by M. Now by substituting the formula of U, it is minus G M M divided by R divided by M. This M get cancelled. You get minus G M by R, and this is the expression for gravitational potential.